So on problem 5 from chapter 5, section 4, homework, we're given a function which we must assume is the function f of x. It looks roughly like this. It's kind of a cubic. And it's got these, it's got zeros at -3, 1, and approximately 3.5. So 3 stops a little bit short of going all the way back down there. So with that in mind, we're asked to compute the integral from -3 to 3 of f of x dx. So the integral from -3 to 3 of f of x dx is going to be the integral from -3 to 1 of f of x dx plus the integral from 1 to 3 of f of x dx. And the reason that we break it down here is that this integral from -3 to 1 is going to be given by this area. And this area is 6, but since it's below the x-axis, this definite integral will be a -6. Then the integral from 1 to 3 of the function will be the area above, which will be a +2. So that's how we get the integral from -3 to 3 to be equal to -4. Any questions? The second part of this question was about the average value, and the average value, it says between, which of the following average values of f of x are larger? Which is, sometimes the phrasing that they use on these problems is kind of cringy, but that's what we got. So which of the following averages on which of the following ranges is the average value of f of x larger? I think is what they were trying to say. They didn't, but I'm guessing that that's what they were trying to say. So the reason it's going to be between 0 and 3 is between 0 and 3, the average value of the function is entirely positive. And between -3 and 3, we have all these negative values are pulling it down. So that's why we would go with the interval from 0 to 3. So on the interval from 0 to 3, the average value is positive, including the area below the curve from -3 to 1. That's going to bring the average down. So actually, that's all. So the average value of f of x is greater on the interval from 0 to 3, since f of x is positive. So if we take the average of we have some positive values. The average value of the function of f of x from 1 to 3 is positive because the function is always positive. When we start adding negative values in, the negative values of the function are going to bring the average down. So the negative values of the function bring the average down. Questions? So if you are struggling with this problem, it might be because of the wording. So if you were struggling with this problem, you can kind of chalk it up to that. And then, of course, Wiley, in defending themselves, would probably say, well, you were able to figure out what was going on anyway, so I don't see what the problem is. And so we'll still be at an impasse, and we'll still be leaving too many things up to computers. Any questions on problem 5? Rad. Let's go on to problem 6. On problem 6, we want to find the area of the region. So we want to find the area of the region between the graph of this parabola and the x-axis for x between 0 and 6. Oops, I spelled 4 incorrectly. So what we'll want to know is, since we're finding the area, we're going to want to make sure any negative area that shows up becomes positive, because that counts as area and it shouldn't be counting against the rest of the graph. So if we think about this, if we look at a graph of this parabola, the zeros are happening at 1 and at 7. So this is where we're going to get the zeros of this parabola. But we want to find the area from 0 to 6. So we want to find the area starting off at 0 and ending at 6. So this is a little bit of a tricky question that I'm assuming is intended, that we don't just integrate from 0 to 6 this function. If we integrate from 0 to 6, this area between 0 and 1 is going to count as being negative, and it will cancel out some of the area between 1 and 6. We want to avoid the negative area from 0 to 1, canceling out some of the positive area between 1 and 6.
But then why do they ask us from 0 to 6?
Because we wanted to specifically to make us look for these zeros and say what's the area going to be, and so that we can calculate the area from 0 to 1, that's going to be negative, and do a separate integral for integrating from 1 to 6. So that was the goal. The goal of the problem is to avoid the negative area from 0 to 1, canceling out the positive area from 1 to 6. So what we want to do is integrate from 0 to 1 the function of, let's see, minus x squared plus 8x minus 7 dx. And then make this negative, change the sign, or just do an absolute value to make it positive, and then add the integral from 1 to 6 of minus x squared plus 8x minus 7. So the point of the problem is to recognize that this function is positive and negative on the interval from 0 to 6, and to separate out the integral from 0 to 1 and take the absolute value to find the area without that being negative. So if we get all these calculations, so if we just, this was me trying to figure out problem 5 and how they got 6. I just couldn't do it. I tried many things. So if we math 9, the integral of negative x squared plus 8x minus 7 with respect to x from, if we just integrate from 0 to 6, then we're going to get a 30. But if we look at the graph, did I put this in? I did. If we look at the graph and calculate the integral from 0 to 6, there's some negative area and some positive area. So we see some negative area and then positive area, and then it stops before it gets back to the x-axis. So what we want to do is calculate the the integral from 0 to 1, that's going to give us negative area. The calculator is saying that's negative. Negative looks like 3 1/3. So the definite integral is giving us a negative 3 1/3. So the area is positive 3 1/3 because area should always be positive. And then if we integrate from 1 to 6, that gives us a value of 33 1/3. So this area so the total area from 0 to 6 is 36 2/3. They said round to 3 decimal places. They said round to 3 decimal places, then they put 36.666. So
Gotta love Wiley.
yeah, thanks, Wiley. So don't round it, just truncate it. But there's plus or minus randomly, oh, yep, tolerance is plus or minus 2%. So 0.666 versus 0.667 will be within your 2% tolerance. Any questions? I know I make fun of Wiley a lot, but it is difficult taking a book and then converting it to a computer, especially when you're not like willing to, probably pay the people that are doing it for you. So I like to hack on Wiley a lot. But I promise you, they could have produced like a near perfect product, and I would specifically find the things that are annoying and make fun of them for it. It's not like they listen to me anyway, so I'm not worried. Any questions? So the trick in this problem was to not just integrate from 0 to 6, but to recognize that this function is going to be negative on some of this interval from 0 to 6. So we got to separate out into 2 intervals and take the absolute value of the negative area. All right, let's pause the video here and talk about what's coming next. I'm just kidding, Wiley. You're a big, powerful company. You can take a joke.